Hello, Math Apps students. Today we are going to talk about probability. We're going to do exercise 7B for homework on page 309. And we're going to start off with a warm-up. Okay, if I have a die and I roll my die, what is the probability that we're going to get a 5? Okay, has everybody seen a die before? How many sides are there? You are correct, there are 6 sides. So my denominator is 6. How many sides have the number 5 on them? Just one of them. So I have a 1/6 chance that I'm going to get a 5. Remember from our notes, it has to be a number greater than 0 and less than 1. Okay, what's the probability of getting an even number? Well, there's 3 even numbers, 2, 4, and 6, right? So 3 out of 6 chances of getting an even number. You could simplify that to 1/2 if you want. I would accept either answers on a test. All right, so today we're going to talk about expected value. What is expected value? Expected value is the number of trials that you have times the probability that we expect to get something. So let's look, for example, let's pretend I'm going to roll a die 50 times. How many times do we expect that we're going to get the number 6? Okay, well, how many 6s are there on the die? 1, right? So the probability of getting the number 6 is 1/6, because there's only one number 6 on the die. Okay, and we're rolling the die 50 times, right? So my expected value is going to be equal to the number of times we're going to roll it, which is 50 times, and the probability of getting a 6th is 1/6, and so if I do 50 divided by 6, we end up with 8.333. So what does that mean? We expect to get the number 6 about 8 times when you roll a die. Okay, so what about the probability of getting an even number? Or what's the expected number of times we're going to get an even number? Well, the probability, you know, is of getting an even is 1/2, right? And so our expected value is going to be equal to the number of times we roll the dice, which is 50 times, times our probability, which is 1/2. So we expect to get an even number 25 times. Okay, your homework for the most part is going to be like that. Let's talk about another example. Okay, this is a problem in the book on page 308. Let's talk about this together. This is example 3. Okay, so this data is in a particular town. People of this age group, this age group, this age group, and greater than 70 staying in hotels, camper vans, tents, apartments. Okay, so if I want to find out how many people were there from age 18 to 30, I need to add up this whole row together. So if I add up this whole row together, I get 305. If I add up this whole row together, I get 529. If I add up this whole row together, this tells me how many people are ages 51 to 70. We get 286. And if I add the bottom row here, I'm going to get 210. Okay, now let's add up the columns here. How many people are there staying in hotels in general? Add all this together, we get 370. How many people are staying in camper vans? We add all this together, we get 419. How many people are staying in tents? You add all these together, you get 247. And then how many people are staying in apartments? You add all these together, and you get 294. You can add this bottom row together, or add this column together. You should get the same number. The total number of people is 1,330. So this is the total number of people coming to town of all ages and staying at all places. Okay, so the first question in the example on page 308 says, if a tourist is picked at random, what age group are they most likely from? Okay, well, the most likely group is going to be, well, the one with the biggest number here, right? Looks like this is the biggest number, so the most likely age group is 31 to 50. So the most likely group from is ages 31 to 50. Okay, let's look at the second example. Find the probability that the tourist is ages 31 to 50. Okay, well, how many people are ages 31 to 50? 529, right? And how many tourists are there total? 1,330. So if I take the number of people of this age group divided by the total number of tourists in the town, we do this divided by this, and we get approximately 0.398. Remember, 3 significant figures, that's what we want to have our answers in. Okay, last question. Okay, if we have 16,000 tourists that come to town, how many of them are going to stay in a hotel? Okay, so first, we need to know how many people are staying in the hotel. And we need to figure out the probability. What is the probability of staying in the hotel? Okay, so how many people are in the hotel in the first place? 370. How many people are there total? 1,330. So this probability is going to give me 370 divided by 1,330, and we get, this is about 0.278. Okay. Now, if I've got 16,000 tourists, how many of them can stay in the hotel? So I can multiply this ratio times 16,000, and I got times, and then we get, this is equal to 4,451 tourists. So this is how many we expect to stay at the hotel given 16,000 tourists come to town. All right, do the homework on page 309. Do numbers 1 through 5. Sounds good. All right, have fun. Good luck.